Good morning, Geometry Honor students. So it's Mr. Chen. Welcome back to my channel. So today I would like to talk about sections 11.5, volumes of prisms and cylinders. Objective for the lesson today, so find the volumes of rectangular prism, triangular prism, cylinders, and hexagonal prism. So formula for finding the volumes of a rectangular prism. So the way to do it, it's always considered the area of the base. If you see that capital B right here, so that it's considered the area of the base. Okay, so this one, area of the base. So times the height, and that will give you the length times width times the height. The way to find the area of the base, so we do know that's a rectangle. So the way to do it, length times width, and then times the height. As you can see that all those edges, they're considered perpendicular. So this one, the diagram is kind of weird, but the thing is supposed to be perpendicular for the corner. Okay, so now let's see what else that we have for the other formula. So the second one, so number 2, volume of a hexagonal prism or hexagonal base prism. Again, in general, the way to find out the prism, the volume of a prism, it's always the area of the base times the height. So we do know that's a hexagon. So the way to find out the area of a hexagon, it's always 1/2 times the apothem times the perimeter of the hexagon, and then the height. So multiply by the height, and then we'll get a volume. So the volume of a triangular prism, similar. So the area of the base times the height. So the way to find out the area of the base is the triangles. So it's 1/2 times the base times the height of the triangle, and then after that you multiply by the altitude, the height of the triangular prism. So we do have two different height here. One is the height of the base of the prism, and the other one it's the height or the altitude of the entire prism. Okay, so now let's see what else that we have for the other formula. Volume of a cylinder. The way to find the volume of a cylinder, it's always pi r square times the height. So we do know that's a circular base, so you want to find out the area of the circle first, pi r square, and then generate it with the height. So multiply that by the height. So now let's do one example. Find the volume of a hexagonal prism with the side lengths of 5 inches and the height 10 inches. So hexagonal prism. So draw the hexagon, and also the bottom base, it's a hexagon. And then connect those vertices. Okay, so all that. This one's supposed to be dotted. Okay, so one thing that we notice, so the apothem, it's already given. Yeah, let me just adjust this bar a little bit to make this one dotted. Okay, so we do know the apothem already, which is, okay, so let's see, with that, the side length of 5 inches. Okay, 5 inches, that's just the side length for the hexagon, and the height of the prism is 10 inches. Okay, so apothem is actually not given. Okay, so the way to find out the area of the hexagons is we already know the side length, so the perimeter is 5 times 6, so which is 30 inches. And the way to create the apothem, so we do know that it's well, if we divide this 360 degree by 6, then you'll get 60 degree. So half of it, then that'll be 30. So 30, 60, 90, and half of the base, which is what, 5/2, which is 2.5. So that means the apothem would be 2.5 times root 3, using the special ratios of the right triangle. So getting the apothem, getting the perimeter, so find out the area of the hexagon first, which is 1/2 times the apothem, 2.5 root 3, and then times 30, the perimeter. So half of 30, which is 15, 15 times 2.5. Okay, so let's see what that is. 25, 75, 2 times 5, 10, 1 times 2, 2, plus 1, 3. So 5, 7, 3. 1 decimal place, so 37.5. Root 3. Okay, so we get the area of the hexagon. Again, the way to find the volume, it's always the area of the base times the height. So which is 37.5 root 3 times the height, which is 10. So it's 375 root 3. And the unit for the volume, so that would be cubic inches. And the area of the square base, the hexagonal base, excuse me, which is square inches. Okay, make sure that you put in the unit as well. Perimeter, inches. Okay, so now let's see what else that we have. Find the volume of the house. So we do know that the top part is considered a triangular base prism. Okay, so we do know that this one is 10, 10. So that means it's an isosceles triangle. So isosceles triangle here. And let's see, this angle could be any, well, this one got to be perpendicular, so one thing I forgot to put it here. So this one is 45, 45, 90 degree triangle. So the way to find out the area of the base, so it's 1/2 times 10 times 10. So which is 50 square meters. And then the other thing that we want to find out here, it's the rectangular prism. So for this part right here, so rectangular prism, which is length times width times the height. Oh, another thing that for the triangular base prism, we need to multiply by the height. So the height right here, which is 20. Okay, so let me fix that part right there. Triangular base prism, so the volume, so 50 times 20, and that'd be 1,000. Let's see. The unit, cubic inches. And then getting the volume for the rectangular prism. So this one, length times width times height, 20 times 12 times 15. So this one we got 240 times 15. So 240 times 15 without using the calculator. So 4 times 5, 20. 2 times 5, 10. Plus 2, 12. 1 times 4, 4. 1 times 2, 2. Combine them. So we got 0, 6, 3. And then bring down to 0 here. 3,600. Combine it with 1,000, so the total volume. So then that will give you 4,600 cubic meters. Okay, so now let's see what else that we have for the other way. So find the volumes. Find the volumes difference of outer and the inner cylinder. So we need to get the volume of this shaded region here. So imagine this one is like paper towel or like toilet paper. So you want to find a volume bounded with the inner radius, with the inner cylinder and the outer cylinder. So we do know that the outer radius, which is 17 cubic meters. So find out the volume. So this one would be considered pi, capital R square minus little r square, and then times the height, because height, that's what they share in common. So pi, outer radius square, so 17 inches square, millimeters square, minus inner radius, so 7 millimeter quantity square, times the height, which is 20 millimeter. So pi, so 17 square, let's see what that is. So 17 times 17, which is 289. 7 square, 49, times the whole quantity, times 20. So pi times 240 times 20. So this one would be pi times 4,800. 2 times 4, that's 8. 2 times 2, that's 4. Bring down 2 zeros. So we got 4,800 times pi. So 4,800 pi. Unit, it's a 3-dimensional, so it's cubic millimeters. Okay, so let's see what else that we have. Okay, that's it. Okay, so again, make sure that you guys need to recognize those formula, the way to apply the formula. So the way to find the volume of a cylinder, the way to find the volume of a triangular prism, 1/2 times b times height times that the altitude of the prism. Volume of the hexagonal prism, 1/2 times apothem times the perimeter of that hexagon, and then times the altitude of the prism. And then rectangular prism, length times width times height. Okay, so thank you for watching the video today. So if you guys do like the video, so please click that bell and then subscribe to the channel. So I'll see you guys next time. Thank you.